Hello everyone and welcome to my tutorial on Surds. Let's learn some key basics on Surds in this video. I will also share with you some worked out examples on the same. Let's begin by defining what a surd is. And we are saying that a surd is an irrational number of the form plus or minus nth root of a. Examples of surds are root 2, the cube root of 4, the fourth root of 5, the fifth root of 7. An irrational number in this case means a number that cannot be written in a fraction form. For example, a over b. A over b is a fraction form. An irrational number like root 2 cannot be written in this form. Next, we're talking about the rules of surds. The first rule is that the product, or rather root a multiplied by root b, is equivalent to the root of a multiplied by b. In the same sense, root a divided by root b is equivalent to the root of a divided by b. But remember that root a plus or minus root b is not equal to the root of a plus or minus b. Let's go ahead and define what conjugate surds are. And we are saying that if a product of two surds gives rise to a non-surd, or rather a rational number, then the two surds are said to be conjugates of each other. If you take one surd and you multiply that surd by another surd and you get a rational number or a non-surd number, then the two surds are conjugates. Examples of conjugates. Number one is an example of a plus the bth root of c and a minus the bth root of c. The product of these two, this one multiplied by this one, will give you a rational number, which is a non-surd, and therefore the two are conjugates of each other. Number two, root a plus root b and root a minus root b, the product of these two gives a rational number, and therefore these two are conjugates of each other. The same applies here. Minus root a minus the bth root of root c and minus a plus bth root of c, the product of these two gives a rational number, and therefore these two are conjugates of each other. So basically changing the sign of it, changing the sign can help get you a conjugate of a surd. For instance, here is a positive, so if you want to get the conjugate of this, you change the sign to negative. Here we've changed the sign from positive to negative. If it's negative, you change it to positive. If it's positive, you change it to negative. Let's go straight to worked out examples, and we'll begin with a question that asks us to simplify. You are given an example of simplify 10 over root 2 plus the root of 8. The solution is, in order for you to solve such, I'm sorry for that, in order for you to solve such, given 10 over root 2, we have to get rid of the root 2 in the denominator. And then we also have to simplify root 8 because it can be simplified further. So to simplify 10 over root 2, we multiply it by the conjugate of the denominator in order for us to get rid of the surd in the denominator. That is, 10 over root 2 is equivalent to 10 over root 2 multiplied by root 2 over root 2. So that this one can cancel out so that you have 1, which means this one is just equal to this one. 10 over root 2 is just equal to 10 over root 2 multiplied by root 2 over root 2. Going on, we have what we get here is that root 2 multiplied by root 2 gives us 2. Remember, in the definition, root a multiplied by root b is equivalent to the root of a multiplied by b. Here that means root 2 multiplied by root 2 is equivalent to the root of 2 multiplied by 2, which is the root of 4, which is 2. So root 2 multiplied by root 2 gives us a 2, and 10 multiplied by root 2 gives us the 10th, not 10th, I'm sorry, is 10 root 2. It gives us 10 root 2. So that 2 cancels out with 10, so that we have a 5. 2 here, 1, 2 here, 5. So that we have 5 root 2. We have simplified the first part of the equation. Going on, we can go ahead and simplify the second part, which is root 8. Root 8 can be rewritten as the root of 4 multiplied by 8, because 4 multiplied by 8 is 8. This can be split into the root of 4 multiplied by the root of 2. But the root of 2 cannot be simplified further. Root 4 is equivalent to 2. So it's 2 multiplied by root 2. So that we have 2 root 2. And then now we can add these two, because this one is equivalent to this and this one is equivalent to this. We can add these two. We add the 2. 5 root 2 plus 2 root 2 gives us 7 root 2. Going on, we have part B, where we have the root of 5 over 2 plus 1 over the root of 3. So in order to simplify this, we begin by getting rid of the root in the denominator. This one is already simplified. So we go ahead and simplify this. To simplify this means we get rid of the root 3 in the denominator, and that is done by multiplying it by the conjugate here and here, so that we have 1 over root 3 being equal to 1 over root 3 multiplied by root 3 over root 3, so that root 3 multiplied by root 3 gives us a 3, and 1 multiplied by root 3 gets us root 3. So that the answer here is root 3 over 3. This one is equivalent to 1 over root 3. And then we can now go ahead and write root 5 over 2, which is this one, plus root 3, the answer we've gotten here, over 3. Then we sum this. The LCM of 2 and 3 is 6. So 2 goes into 6 3 times. 3 by 5 gets us 3 root 5. 3 multiplied by root 5 gets us 3 root 5. Then 3 goes into 6 how many times? 2 times. So the 2 multiplied by root 3 gives us 2 root 3. It's addition. So 3 root 5 plus 2 root 3 over 6. That is the final answer. Moving on, let's look at another example here where we need to evaluate. Given a set like this, this falls under multiplication of surds. This is 5 minus root 3 in bracket multiplied by root 3 plus 6. So in order to multiply, in order to work out this, you take the first one multiplied by the whole of this in the second bracket, and then minus the second one multiplied by the whole of what is in the second bracket. That's basically what is done to multiply numbers in the two brackets. So it is 5 into what is in the second bracket, root 3 plus 6, minus root 3 multiplied by root 3 plus 6. So that 5 multiplied by root 3 gives us 5 root 3, then plus 5 multiplied by 6 giving us 30, and then minus root 3 multiplied by root 3 is 3, and then minus root 3 multiplied by 6 gets us minus 6 root 3. So the 30 minus 3 gets us 27, and then 5 root 3 minus 6 root 3 is the same as 5 minus 6. 5 minus 6 is minus 1. So we are having minus 1 root 3, which is just the same as minus 3. It is the same as 27 minus root 3, because it's 1 root 3. 1 root 3 is just the same as root 3. The next example here, multiplication of surds. We take 3 into the whole of this, and then minus root 17 into the whole of that. So that 3 multiplied by 3 is 9, 3 multiplied by root 17 is 3 root 17, and then minus 3 root 17, and then minus 17. So that this one cancels out with this, that is 3 root 17 minus 3 root 17 gives us a 0. So that we are left with 9 minus 17. So 9 minus 17 is minus 8. So that's the answer. We've already evaluated that. Let's look at a more complex example. Asked to simplify question number 1 here, that if you're given 3 plus root 5 over 3 minus root 5, how would you go about this? You look at the denominator. The denominator has a root, and we have to get rid of the root in the denominator. So what do? We multiply by the conjugate in the upper side and in the lower side. So that 3 plus root 5 over 3 minus root 5 is equivalent to 3 plus root 5 over 3 minus root 5 multiplied by the conjugate. That is, the conjugate, the sign changes, so that it's now 3 plus root 5 over 3 plus root 5. The conjugate of 3 minus root 5 is 3 plus root 5. So that the conjugate of 3 plus root 5 is 3 minus root 5. So the two are conjugates of each other. So multiplying across this gets us 3 into the whole of this, and then plus root 5 into the whole of this, and then over 3 into the whole of that, then minus root 5 into the whole of that. So that in the numerator we are having 3 by 3, which is 9, and then 3 by root 5 gives us plus 3 root 5, and then plus root 5 multiplied by 3 gets us 3 root 5, and then plus, remember root 5 multiplied by root 5 is 5. Let's move into the denominator. So that 3 multiplied by 3 gives us 9. 3 multiplied by root 5 gets us 3 root 5. And then minus root 5 multiplied by 3 gets us minus 3 root 5. And then minus root 5 plus, multiplied by plus root 5 minus root 5 multiplied by root 5 gets us a 5. So it's minus 5. 3 root 5 minus 3 root 5 cancels out, so that the answer is 0 here. Then we are left with 9 minus 5 in the denominator. 9 minus 5 in the denominator. So 9 minus 5 is a 4. And then here 3 root 5 plus 3 root 5, that is 6 root 5. And then we have 9 plus 5. 9 plus 5 is 14. Then plus this, which is 6 root 5. So we are having 14 plus 6 root 5 over 4 as the answer. But that can be simplified into this, so that we factor out 1 over 4. 1 over 4 into 14 plus 6 root 5, which is the same as a half into bracket 7 plus 3 root 5. Into the next question. It's root 3 plus root 2 over root 3 minus root 2. The solution to this, in the denominator we are having a surd, and we have to get rid of the surd in the denominator. And how do we do that? We multiply this by the conjugate of the denominator, and the conjugate is found by just changing the sign. If this is minus, the conjugate will have a positive, because that root 3 plus root 2 over root 3 minus root 2 is equivalent to the same multiplied by root 3 plus root 2. Now this is the conjugate over that conjugate. We multiply that. This one is equivalent to this product, so that we're having root 3 multiplied by the whole of this plus root 2 into the whole of that over all over root 3 into the whole of that, and then minus root 2 into the whole of that. And then now we can multiply. Now root 3 multiplied by root 3 gives us a 3. Root 3 multiplied by root 3 multiplied by root 3 gives us a 3. And then root 3 multiplied by root 2 gives us a root 3 multiplied by 2. And then plus this, the same, gives us root 2 multiplied by root 3 gives us the root of 2 multiplied by 3. And then plus root 2 multiplied by root 2 gives us 2. Moving on, root 3 multiplied by root 3 gives us a 3. And then this one by this gives us root 3 multiplied by 2. And then minus root 2 multiplied by root 3 gives us the root of 3 multiplied by 2. So that here we have minus root 2 multiplied by positive root 2. This and this gives us a 2, so that we have minus 2 here. We are having 3 plus 2, which is a 5. And then root 3 multiplied by the root of 3 multiplied by 2, which is the same as the root of 6. So it's the root of 6 here and the root of 6 here. But 1 root 6 plus 1 root 6 gives us 2 root 6 over root 3 multiplied by 2. The root of 3 multiplied by 2 minus the root of 3 multiplied by 2 cancels out. It's equivalent to 0. so that we're left with 3 minus 2, which is 1. 5 plus 2 root 6 over 1 is just the same as 5 plus 2 root 6. Then, thanks for watching. If you have any questions concerning surds, please feel free to ask in the comment sections below. I will gladly respond. Thanks again for watching.